This is the learning goal. The student will understand the context of key ideas related to the topic. Mason dying a slow death. No. Designing a donut box.
I told you we should.
Next, the student will understand the following vocabulary. They gave me 3 vocabulary terms. The first one is donut.
I don't know what a donut is.
A piece of sweet fried dough that is often shaped like a ring.
Wow. Oh wow. Couldn't have guessed that.
We're not done yet. The second is cardboard. A stiff, thick kind of paper that is often used for making boxes. Yes. Donuts come in many different shapes and sizes.
Wow.
Can anyone give me an example of a shape or size of a donut? Thank you for raising your hand. All right. Who's got a shape or size? Justin.
A circle?
A circle.
Wow.
Bryce.
A rectangle.
A rectangle. Maybe an apple fritter comes in rectangles. Mason. Don't be funny. Oh, this Mason. Good, good. A triangle. There are triangular donuts. Anybody else?
A sphere.
A sphere like a donut hole.
A ring.
A ring like a donut with a hole in the middle. Some people, other classes had twist donuts. You know, the cinnamon twist.
Oh, yeah.
So, you got another one?
Square.
I think we said square. Somebody did, didn't they? Okay.
Square.
All right. So allow students to provide examples of different types of donuts, making sure that the students mention that donuts can be circular. You guys are so good. I'm so proud of you. Next, facilitator says, usually donuts are purchased by the dozen, but they can also be purchased individually. What should be considered, don't talk, what should be considered when someone is designing the box to hold a dozen donuts? Give me something that should be considered if we're designing a box to hold a dozen donuts. Carter.
Use as little cardboard as possible.
We want to use as little cardboard as possible. Love it.
Enough space.
Enough space for the 12 donuts, right? What else? Chandler.
The size of the donuts.
We need to consider the size of the donuts. If they're big donuts, we need a bigger box. If they're little donuts, smaller box.
Make sure it can open.
I hate it when I can't open my donut box. Yes. Second, the shape of the donuts. Okay. And
how much space a donut takes up.
And how much space the donut takes up. Okay. Great things. Next thing here. Does anyone know how the owner of a donut shop decides to charge customers for a dozen donuts? Let's think about this. How would they figure out the cost of a dozen donuts? Give me something they would consider when they're figuring out the cost of a dozen donuts. How would they determine the price?
Well, they probably want to make a profit, so how much everything costs to make that donut?
Exactly, the expenses of making the donut. So what kind of expenses would they have? What would they have to pay for making the donut?
How much dough they need to use?
Dough. Frosting. Filling. Sprinkles. Oh, is that what you're going to say?
Fryer.
A fryer, yes. Let's not just talk about the food. Labor. We have to pay employees.
Electricity.
So there's a lot of different factors that come into play when we need to figure out the cost of our donuts. We got to know how much everything costs. And it says allow the students to discuss setting product prices. Make sure that students discuss cost as a factor in the price. Discuss different types of boxes that can be used to hold a dozen donuts and the requirements of the boxes. Make sure that the students discuss cost, shape, and size as some considerations. All right, I gave you guys this right here. Raise your hand if you have the volume of this first one. What was the volume? These could be our donut boxes, couldn't they? Okay. What'd you get?
60 inches cubed.
60 inches cubed. What did you get for the volume of this box? Mason? Oh, so what does that tell us? They have the same volume. They have the same amount of space inside the box, right?
Yes.
Those boxes are the same size when we think about volume or space inside. Are we crystal clear with that?
Yes.
The surface area of the box. Why would I ever want surface area of the box? Why would I ask you find the surface area, Kenzie?
To see like which one uses less of it.
Of the cardboard,
Yeah.
right? Remember, these boxes, if we split them up, we could make a net. Remember our nets that look somewhat like this, or we would draw them separately. Are you with me? That is the amount of material used to make the box, isn't it? If I unfold a box, like a Kleenex box, it would unfold into a flat piece of cardboard, and that would be like my net, wouldn't it? What'd you get? What'd you get for the surface area of this box? What was it? Wesley.
94 inches square.
Good, I'm glad you said square inches. It is, it's 94 square inches. So this one, how dare you defy me? What did you get for this one, Stephen?
128 inches.
128?
Yeah.
Is that right?
Yes.
Okay. What can you tell me? Somebody be a donut expert and tell me, what do you know about these boxes? What would you do?
That one, they hold the same amount of donuts, but that one uses less cardboard.
So if we're trying to make a lot of money on our donuts, we're gonna use this one, right? It's gonna have a less expense to make the box, isn't it?
Yes.
So, oftentimes we don't realize that. We think that if it's a box with the same volumes, they're gonna take the same amount of material to make them. But that is not the case. It's kind of weird, isn't it? So, how can we apply some of this? What shape of a box is gonna, when we're making our donut box, what shape do we wanna be closest to? What shape is this closer to than this one? You know what I'm asking, kinda? Skylar?
Like a cube, square.
Yeah, like a square box or a cube, right? We want these lengths, widths, and heights to be as close to the same value as we can get. 3, 4, 5 are pretty close to each other. 2, 2, and 15 are a ways away from each other. Does that make sense? The most efficient box is a cube. That's the most efficient. We use the least amount of paper or cardboard to make a cube box, and we get the greatest volume. That's just true. Well, if we made spheres would be the best, but we don't make boxes that are in spheres. Okay. So if we're making a rectangular prism, we want to make it like a cube, as close to a cube as we can get, and then we'll use the least amount of material. I think you guys did it. Last things. Facilitator says, today we completed an activity about donuts and donut boxes. These ideas may help you when you complete your performance task. Next week you're going to do math Mstep on Monday and on Thursday. So you might have a performance task on one of those days, and it just might deal with donuts. Who knows? Are there any questions? All right, you are ready to complete the donuts